Frank, what is a turbo wing, and how does it work?
Fred, a turbo wing is a simple combination of a wing, as you see here with this model, and a rotor. Okay? The combination of the wing and the rotor, when the combination is moving forward, creates a certain type of airflow over the wing, and most of the uniqueness of the flow is produced by the flow of the rotor as it moves forward. But that combined flow is such that we develop a tremendous amount of upward force or lift, and we develop a significant amount of forward force. Okay? Now, I'd like to really spend another minute telling you a little more in detail how the flow reacts over the wing, because it's important that you do understand the system, which has such high efficiency. In order to do that for you, Fred, we have prepared a chart. And if you look at the chart, you can see that we show in the upper portion of the chart smoke flow over a wing, and incidentally, these smoke flows were taken in a wind tunnel. And in the upper chart, part of the chart, the smoke flow is with the rotor not operating, so you have the flow that you more or less see over a conventional wing. And in the lower part of the chart, the rotor is operating. The rotor is turning, if you wish. And again, we show the smoke flow over that, of the wing with the rotor operating. And if you look at the upper and lower photographs, you will note that the lower photograph, which shows the wing with the rotor operating, has a very, very significant arching, if you wish, of the flow over the wing compared to the flow of the wing when the rotor is not operating. It's this increased arching of the flow that produces the significant increases in lift and forward force that I have mentioned to you. I'd like to have you join me in viewing a film clip, which is literally a history of the full-scale operating hardware that we have built and we have operated over a period of 10 years. Our first turbo wing boat, we operated this boat for around 300 hours in rough water. This is a remotely piloted tandem wing watercraft. A 15-passenger craft that's operating about 40 miles an hour. This is the first recreational watercraft. A good shot of the flat turning capability of a Campbell whaler boat retrofitted with a turbo wing. Boat's operating at speeds around 40, 50 miles an hour. Another shot of the same boat with inboard engine. This is a Sea Ray cuddy craft equipped with a turbo wing, operating in the ocean.
Climbing out at 60 knots. appears to be just about a level attitude at a 110 knots. Now slowing through 70 knots. Slowing through 64 knots. Get quite a bit of nose up now. It's like about 15 degrees nose up. Okay. Actually, and an indication of zero airspeed on the helicopter that time.
During the month of March 2004, we flight tested a Cessna 337 retrofitted with turbo wings, as illustrated in the chart. Note that for this test bed, each wing panel is equipped with 2 rotors instead of 1 rotor per wing panel that we had for the Cessna 207 test bed. Our continued research indicated a more favorable influence on wing lift compared to 1 rotor per wing panel. For this flight test, we flew in formation with a conventional wing 337 aircraft to clearly demonstrate the low speed, short takeoff distance, and higher rate of climb of the turbo wing compared to the standard Cessna. Each of these aircraft weighed 4,200 pounds, the maximum takeoff weight for a standard 337 aircraft. Note the short distance takeoff run of the turbo wing and its higher rate of climb compared to the standard 337 Cessna. The application of the turbo wing technology to aircraft and watercraft will provide significant improvements in the performance of these systems.